Hello everyone, hope you're all doing good. So today we are here for grade 8 maths. The chapter name today we discuss that is the proportional relationship, and here are the list of the lesson. So the first lesson today we covered, which is write equation for proportional relationship, identify the proportional relationships, find the constant, solve proportionality, word problems, solve problems involving proportional relationship. So you can find all the lessons on aplusstudent.com. You have to log in by using their email and password that is provided by the administrator. Go to the subject tab, select maths from there, and go to the grade 8. And here is the list of the lessons, list of the chapters. So we are on proportional relationship. This is the name of the chapter. And the lesson today we covered, which is write equation for the proportional relationship. So here we go with it. All right, so let's get start. Wait, let me just checking my mic and everything. All right. So here, write an equation for the proportional relationship. Fill in the missing numbers to complete the linear equation that gives the rule for this table. Okay, so here we are just going to finding it out the rule of this table. As we know that first of all they are saying that find m. Okay, and so look at the table and notice every times the x time terms go up by 1, so the y terms go up by 6. This means that m is equals to 6. So when we see here all the things, so look at here, x is 1, 2, 3, 4, 5, and y is 6, 12, 18, and 24. It means that you are going to multiply 6 times 2 is 12, 6 times 3 is 18, 6 times 4 is 24. This is basically the multiplication of each number with the 6. Okay, so we can say that what is your y, that is equals to mx plus b. Okay, this is your pair and your m is same for every case, and your x is changes, like for the one value it's putting 1, then for the second value you're going to put 2, then for the third value you're going to put 3, then for the fourth value you're going to put 4. So what's for that? So the rule is here y is equals to 6 and x. So in place of 6 as it is, and in place of x putting 1, so this is 6 times 1 is 6, then it's 6 and 2, 6 times 2 is 12, then it's 6, and in place of x we're going to putting 3, then that is 18. And now for the last but not least, which is 4, that is 24. Okay, this is the way that we get it. So in this way you are going to, is my screen is showing or not? Yeah, I think so, everything is all right. So now let's do the next one. What's for the next, which is for that, like for example, if you are, if we can see that, like we are just going to check the other question. Okay, let's do it with this one. So here, fill in the missing number to complete the linear equation that gives the rule for this table. Okay, that give the rule for this table. Now when we see the rule, x values it's 1, 2, 3 up to so on, that is for 4. And when we see the y values, so this is for 21, 42, then it's 63, and then it's basically 84. Now check it out. As we know that your m is your first value. Okay, what is your m? Your m is your first value. And when we can see that your m is your first value, and which is 21, and what is x? 21 times 1 is 21. Again y is equals to mx. So y is equals to m as it is, and in place of x we're going to put the values. So what is m? This is 21 times 1, which is 21. Then for 21, and in place of x I'm going to put 2. This is for 42. Now for third value we're going to put 21 with the 3, that is 63. Now for 21 with the 4, which is 84. Understand, in this way we are going to solve all these basically things one by one. Okay, now let's see. For example, we are going to solve some test questions for that. Let's do it. Fill in the missing number to complete linear equation that gives the rule for this table. So the rule is here, x values are given, it's 1 to 4, and y values are given, which is 12, 24, 36, and 48. Okay, so these are all the values. When we see all these values, just give me a second. So your x values is 1, 2, 3, and 4, and your y values are 12, 24, 36, and 48. Okay, so we are going to solve this by using that method. Same the thing, y is equals to 12 and x. In place of 12, first of all, putting x value is 1. Okay, then just putting the x value 2. 12 times 2 is 24. Then putting the x values 3, that is 36, and x values 4, which is 12 times 4 is 48. All that values one by one we are going to put it. Okay, so this is 12 and x. So let's do with it. So here is the right answer. Now, this is the question. Fill in the missing number to complete the linear equation that gives the rule for this table. So x values are given, which is 1, 2, 3, and 4, and y values are given, which is 23, 46, 69, and 92. Same thing, as we know that what is your y? Your y is always the first value, and the first value is here 23 with the x. Okay, this is 23 with the x. Let's check it out. Are these the same values? When we're going to put in place of x is 1, this is 23. In place of x we are going to put 2, that is 46. In place of x we are going to put 3, that is 69. In place of 4, this is 92. 23, 46, 69, and 92. Okay, all these four values. So this is the same thing we are getting. So here we go with this one and then just click it out. Hope you guys understand this lesson. So solve the rest of the test questions by yourself. So here we have done the lesson. Write equation for proportional relationships. So identify the proportional relationships. Okay, let's do it. So select the graph that shows a proportional relationship between the x and y. So for that thing, what we see, so we determine basically whether the graph shows like a proportional relationship between some x values and some y values. So when we see, it's a basically straight line and passing through the origin. Look at here, this is the very straight line that is passing through the origin. When we see it, so this graph passes through the origin, but this is for the proportional relationship. Okay, so what is the proportional relationship? In which that the graph basically cuts the x and y values, passes through the straight line through the origin. This is the definition of proportional relationship. Now let's see this question. This is the question. This is not a straight line. Okay, but it passes through the origin. Origin is the center, like the center. What does the center means? Like for example, if I'm going to draw the graph, like this is your graph. When I'm going to draw, so this is your x values and these are your y values. So when this is your origin, okay, that is your origin. Understand? So in that question, when we see that it passes through the origin, but it's not a straight line. Look at here, it passes through the origin, but it's not a straight line. So we can say that this is not a basically proportional relationship. Now look at this one. This is the graph which is a straight line and as well as passing through the origin. So we can say that this is your proportional relationship graph between the x and y. All right. Let me just tell you again. Look at here. If you have a question, if you have a graph, sorry, like this way, some graphs like which are passing through, like look, it passes through the origin, but it's not a straight line. Okay, Like the line is like in the form of this way. It's not a straight line. When the line is like in this way, the line is like in the form of this way. So this is the straight line graph. So we can say that this is basically a straight line. This is a linear, you can say that proportional relationship. And when, for example, here is the line, it's like a blue line, okay? Like it's like a blue line, and we just colored this line as well. Yeah, these are all different lines we are getting. Yeah, now this is different line. So look at here, these are the three lines that we draw it here. First one is the yellow line. This shows a proportional relationship basically, okay? Because in that thing, the line passes through the origin. Got it? So this one is, what is this line? This line shows the proportional relationship because it passes through the region and it's a straight. Now when we see the second, let's check the second one. So when you are going to see the second line, okay, this is a basically like passes through the origin, but it's like in form of this way. Look, like it's some tilted form. So we can say that this is not a proportional relationship. Now look at the third line. This is a straight, but it did not passes through the origin. So this is also not a proportional relationship. Understand, like, what is basically the meaning of the proportional relationship? That is thing. Okay, look at this line. Okay, now you all guys tell me, is this line basically shows a proportional relationship or not? Everyone think about it and then tell me. So this is a graph that shows a proportional relationship between the x and y. All right, this is the thing. Now let's do some test questions for that. Let me just select the graph that shows a proportional relationship between the x and y. Look at here, the first graph. This is value of y, this is value of x. And here the line that shows a basically straight line, and between the x and y it passes through the origin. Like here is the origin. Okay. Now when we see the second graph, look at here the second. So when we see the second, sorry, open the second. This is a basically x, and you can say that x and y. Okay, this is x and this is y line, and here is a straight line. Line is straight, but is it passes through the origin or not? No, it passes through like here. Here is the point that it passes through. So we can say that this is not basically the thing that we are going to put. So what's the answer for that? The part A, in which a straight line passes through the origin. Okay. So now check this one. Select the graph that shows a proportional relationship between x and y. So here are the two graphs. Look at here the first graph. This is in between. This is the straight line which cuts the x and y values. Look at here, and it passes through the region. But when we see the second line, This is a straight line, but is it passes the origin or not? No, it's not from the origin, it's from the 3. So we can say that this is not a proportional relationship graph. So we are going to put this is not a proportional relationship between the values of x and y. So this is the first one. Then let's check. And this is the right answer. Select the graph that shows a proportional relationship between x and y. So look at here. Straight line, this is for y, this is for x. And look at the second. This is also the straight line, but is it passes through the origin? No. So we can say that this is not. So here is the right answer. Okay. Hope you guys understand this lesson as well. So now let's discuss the next lesson. So solve the rest of the questions by yourself. I'm going to repeat for one time what is basically the meaning of the proportional relationship between the x and y. The meaning is that here is the graph that we are going to put, and the 3 lines I'm going to draw. The yellow line, which is the straight line between the x and y, and it passes through the origin, so we can say that this is the proportional relationship between the x and y. But when we see the orange line, this is passes through the origin, but it's not a straight, it's like in the form of parabola, so we can say that it's not in parabola. You can say that in parabola is like the shape like this way. Okay. So here is the third graph, which is the totally straight line, but it not passes through again the origin. It's a straight line, but it cuts the graph here. So we can say that this is again not the proportional relationship between these two. Okay. So hope you guys understand this lesson. So here is the next, which is find a constant of proportionality word problems. So, Kylie cycled a total of 8 kilometers by making 4 trips to work. Later on, he cycled 12 kilometers during 6 trips. How many kilometers does Kylie cycles per trip? Okay. So, as we know that how many number of trips, like these are, firstly they are saying that 4 and how many kilometers in the 4 trips. Number of trips are 4 and 6. And how much distance when he covered the 4 trips, that is 8 meters, and when he basically cycled 12 kilometers during the 6 trips. So now constant of variation is divided by y values over the x values. Okay, what we see, how can finding it out, the constant of variation, constant of variation. So we are going to find the constant of variation y by x. So look at here. What's the first value of y, which is 8 over 4, 12 over 6? 8 over 4. And the second is 12 over 6. This is also the y over x. So let's check. 4 times 1 is 4, 4 times 2 is 8. Answer is 2. 6 times 1 is 6, 6 times 2 is 12. Answer is 2. Is this the constant? Like, look at here. When we see the constant of variation is 2, so it means that Kylie cycles 2 kilometer per trip. Understand? This is the constant of variation, because in the question we are going to finding it out the constant of proportionality or constant of variation. Understand? Okay. So look at here the question. Andrew ran a total of 10 miles over the course of two track practices. Then, later in the season, he ran 15 miles over the course of three track practices. How many miles does Andrew run per track practice? Okay, so 10 miles over the two and 15 miles over the 3. So first of all, 10 by 2 and 15 by 3. Got it? 10 by 2 and 15 by 3. Let's check. So y by x, 10 by 2. Y by x, 15 by 3. Let's check. So 2 times 1 is 2, 2 times 5 is 10, and 3 times 1 is 3, 3 times 5 is 15. So it's 5 and 5. Understand? So here we get the answer 5 and 5. Janelli grew 9 planters with 3 seeds packets. Then later in the season, she grew 15 planters using 5 seed packets. So how many planters can Janelli grow with one seed packet? 3, 5. Number of seeds per packets for X values. How much? 3 seed packets for 9 planters and 5 seed packets for 15 planters. The same thing, just going to divide 9 over 3, 15 over 5. Okay, and then check what is the constant of variation. Same thing. Let's do some test questions. Okay, look at here. The test question is same for Janelli. Grew the 9 planters with the 3 seeds packets. Then later in the season, she grew 15 planters using 5 seed packets. So how many planters can Janelli grow with one seed packet? So when we see that, it's 9 over 3 and 15 over 5. Let's check. 9, 9 over 3, 15 over 5. So 3 times 1 is 3, 3 times 3 is 9. And 5 times 1 is 5, 5 times 3 is 15. So this is the same thing. So when we see this is 3. Harold's Auto Wash had revenues of $12 from two customers. At another point, the auto wash earned $18 in revenue from three customers. First is 12 from the two customer and 18 from the three customer. So how much revenue does the Harold's Auto Wash have per customer? So we are going to finding it out for the per customer value. Okay, so just simply dividing 12 over 2 and 18 over 3. Let's check. When you are going to divide y by x, constant of variation, 12 by 2, sorry, yeah, it's 12 by 2, and then it's y by 6 x is 18 over 3. So 2 times 6 is 12, 3 times 6 is 18. So let's check, is there any option for 3? Sorry, 6. Yes, 2 times 6 is 12, 3 times 6 is 18. So constant of variation is 6 because both have same values. So we go with this one. So Harry took a total of 12 quizzes over the course of 6 weeks. So after the school vacations, he took 14 quizzes over the Span of 7 weeks. So how many quizzes does Harry take per week? Okay, 12 quizzes over the 6 week and 14 quizzes over the 7 week. So just dividing 12 over 6 and 14 over 7. And when we're going to divide, we see that what's the answer? 12 over 6 is 2, 6 times 2 is 12. 14 over 7 is 7 times 2 is 14. So the Harry per week is 2. Anita took a total of 8 pages of notes during 2 hours of class. Then later in the year, she took 16 pages of notes during 4 hours of class. How many pages of notes does Anita take during an hour of class? 8 pages, 2 hours. So 8 by 2. And 16 pages of notes during 4 hours. So 16 by 4. So 2 times 4 is 8, 4 times 4 is 16. So the constant of variation is 4. So we go with this one. So let's click and check. This is the right answer. Hope you guys understand this lesson as well. So what we do in this lesson, we are going to finding it out the constant of variation, just simply dividing the values of y over the values of x. Okay, and then we are finding it out the answer. So solve the rest of the test questions by yourself, everyone. So here is the last um, lesson for this chapter. Let me just check. Is that one? Solve problem involving proportional relationships. Okay, this one. Let's open. So here, solve the problem solving proportional relationships. This equation shows how the total cost of visiting the art museum as a member is related to the number of visits. C is equals to 5V. The variable V represent the number of visits to the art museum and the variable C represent the total cost of those visits. So for a member of the art museum, what is the total cost of 4 visits? Just you are just going to put, they are saying that V is the number of visits and how much the number of visits are given 4. So in place of V, we are going to put the 4. So C is equals to 5V because V represent number of visits they are saying that it's 4. So C is equals to 5 times 4 is 20. So this is basically the total number of, you can say that, a member of the art museum if the total cost is 4 visits. Okay, so we are going to finding it out the cost of the visiting the art museum as a member is related to the number of visits. Understand or not? Okay, now let's do the next. So this equation shows how the time required to ring up a customer is related to the number of items being purchased. T is equals to 3P and P represent the number of items being purchased and T represent the time which is required to ring up the customer. So how long does it take to ring up a customer with 2 items? So in 2 items they are given. So in place of P we are going to put 2. Okay, so T is equals to 3P here. and p is given. How much the p that are given, which is 2 atoms. Okay, so put value of p in equation. So t is equals to 3 into 2. So t is equals to 6. And this is your answer. Okay. This equation shows how the total number of necklaces Vande owns is related to the amount of money she spent on the additional necklaces. N is equals to D. Okay. The variable D represents the number or amount of money she spent on additional necklace. So what is D represent? Amount of money. And the variable N represent the total number of necklaces. Now they are saying that with $10 to spend on new necklace, so how many total necklaces? Spending money is given. So how many total necklaces? It means that if they spend $10, so it means that N is equals to D. So just these both are same. So 10 is equals to 10. Okay. Now let's do some test questions. So this equation shows how the total number of books Jack has read depends on the number of months he has been a part of the book club. B is equals to 7m. I'm just checking my mic. So the variable m represents the number of months he has been a member of the book club, and the variable b represents the number of books that he has read after belonging to the book club for 1 month. So how many books will Jack have read in all? So b is equals to 7m. So number of m they are given, which is 1. So it means that when you are putting the value of m in this equation, so b is equals to 7 into 1. So 7 times 1 is 1. Because how many number of months are given? They are saying that m represent number of months. And how many number of months are given? 1. So 7 times 1 is 7. So go with it. This is the right answer. Okay. This equation shows how the amount of time that a receptionist named the Williams spent on the phone is related to the number of phone calls he routes to employees. T is equals to 5p. So variable p represents the number of phone calls he routes, and variable t represents the number of minutes that he is on the phone. If he routes one phone call, so how much time will William have spent on the phone in total? So P is basically 1 because that is the phone call. So T is equals to 5 into P. In place of P, we are going to put 1. So 5 times 1 is 5. Okay, this is the right answer. Okay, only solve this one, then we'll finish up the class. This equation shows how the number of flowers Anita can have in her garden is related to the number of seed packets she purchases. So F is equals to 9s. The variable s represent the number of seed packets she purchases, and the variable f represent the total number of flowers in the garden. With one seed packet, how many total flowers can Anita have in her garden? So what is s? S represent number of seed packets. And what is F? That represent the total number of flowers. F represent the total number of flowers. S represent the number of seed packets. Okay. So with one seed packets, how many total flowers can Anita have in the garden? So with the one seed packet, so in place of S, we're going to put the 1. So 9 times 1 is 9. So let's check. Yeah, this is the right answer. This is the same question as we have done before. Hope you guys understand this lesson as well. So today we covered the grade 8 maths. Chapter name today we discuss, which is the proportional relationships, and the lessons are: write equation for proportional relationships, identify the proportional relationships, find the constant of proportionality, word problems, solve problems involving proportional relationships. If you still need any help in any of the questions, so you can contact the tutors. There is a basically the chat button on your uh, A plus app. Look at here the chat button, just click over there. Okay, like in this kind of chat is open, so you choose a department which department that you need help with, like in maths help and English help and anything. Okay, so you just click maths help here, put their name and then just send it. Okay, then this is the easy way to contact us. So hope you guys understand the method as well. So for now, have a good day, you all. Bye.